Next chapter is chapter 5, which is the quadratic functions and complex numbers. The essential questions that we're going to cover in this chapter first are talking about what are complex numbers, how do we simplify them, add them, subtract them, multiply, and divide them, how are they used in the real world, how are they related to quadratics, and how do we find an equation of a quadratic given its roots, and finally application problems. So the first thing we're going to talk about is quadratic functions and how we solve them, and then you'll start to see where complex numbers come into this. So what is a quadratic function? It has an x squared in it. It's supposed to be a 2. What does it look like when you graph it? And that is a parabola. Not very neat. How do you solve or find the roots? So to do this, we set the equation equal to 0. Not working. And then solve. And when do you see a quadratic function in real life? So think about, where do you see parabolas in the real world? One thing that you see is satellite dishes. They're parabolic in shape. So think of some other ones, and we'll talk about that in class. Where do you see them? Next page. First, let's talk about the conic sections. In this class, we cover the circle and the parabola and the hyperbola a little bit. The hyperbola we just did with the rectangular hyperbola. We don't really cover the ellipse, but conic sections are the intersection between a cone and a plane. So if you cut it parallel to the base, that's where you get a circle. If you cut it at an angle to the base, you get an ellipse. If you cut it through where it touches the base at an angle, there's your parabola. And the hyperbola, it's hard to see the difference between the parabola and the hyperbola. The hyperbola actually will cut through on 2 cones, but it's more perpendicular to the base, where the parabola is at an angle. So since we're talking about quadratics, which are parabolas, let's look at the idea of defining it. So we know the equation looks like an x squared, but the actual definition of a parabola is taking a focus point P, a line called the directrix, and this line is created, the parabola is created by the intersection of where the focus point meets the directrix. So if you kept folding this piece of paper down and meeting these two together, you would start to see that this parabola would be generated. Next page. Okay, so we're going to talk about one of the ways to solve quadratics. So far you have learned a couple of these. The 4 different ways to solve quadratics are to reverse FOIL, or which is actually called factoring. Completing the square, that's what we're going to do today. The quadratic formula, we've touched on that. We're also going to do more with that. And then looking at it graphically, we'll do in class. So the one that you already know, we kind of know the quadratic formula a little bit. We've done that. But really the reverse FOIL or factoring, you've done that quite a bit since 9th grade. So one of the big things that we want to talk about is that if you look at the graph of a quadratic, you look at the graph of a parabola, the solutions or the roots are where it crosses the x-axis, except sometimes the roots aren't real numbers, and that's where we're going to start talking about complex numbers. So at the moment, the answer is yes, that's all you've learned is where it crosses. But what if a parabola doesn't cross the x-axis? We're going to talk about what those roots are, or solutions. Okay, next page. So, completing the square. We'll talk about how to complete the square. So, first we want to talk about what do you mean by square? Square is a perfect square, meaning something like x plus 5 quantity squared. That's a perfect square. So, basically, we can use this method. We can use it at any time, but it works really well when we cannot reverse FOIL. So we've talked about factoring reverse foiling in the quadratic formula, and here is another method that we can solve a quadratic that doesn't factor. All right, so the first thing that we're going to do is we're going to take the constant term and move it to the other side of the equation. So we have x squared plus 2x equals 1. So we have the x squared plus 2x, and we're going to move the 1 to the other side. The other thing to remember is that a quadratic typically comes in the form of ax squared plus bx plus c. So the a is the coefficient in front of x squared, b is the number coefficient in front of x, and the number is the constant term. So our next step is going to take our b term, divide it by 2, and then square it. Okay. So your b term, divide by 2, then square it. So our b term is 2. Two divided by 2 is 1. 1 squared is 1. Then the answer that we get, we're going to add to both sides. Okay, so we have x squared plus 2x equals 1. Then I'm taking my answer that I got here, and I'm adding it to both sides. So move the constant term, take your b term, divide it by 2, and square it. Take your answer and add it to both sides. Now what you're going to do is reverse FOIL the left-hand side and simplify the right-hand side. So if you go to reverse FOIL this, and notice, go back to the beginning, notice how this was not reverse FOILable. So we have x plus 1 quantity squared, x plus 1, x plus 1. And if this doesn't come out to a perfect square, x plus 1, x plus 1, something that's not a perfect square, something's wrong, because that's the purpose of this. Okay? So move the constant term, take the b term, divide it by 2, square it, add your answer to both sides, reverse FOIL. Okay, now we want to find the roots, which means the solution, so we're going to keep going. We want to find the answer to this. What does x equal? So to solve this, the next step would be to take the square root of both sides. Okay. So as I take the square root of both sides, right, I'm going to take the square root of this side. Remember that when we're solving, it's both positive and negative roots. So on this side, the square root of something squared is just the something. And over here, I have positive and negative square root of 2. To get x alone, we subtract 1. So we get x equals negative 1 plus or minus the square root of 2. Okay? Again, a little recap. Move the constant term, take the b term, divide it by 2, then square it. Take the answer, add it to both sides, and then finish solving, which involves taking the square root and not forgetting that when we take the square root, it's both the positive and negative. So not too hard algebraically. Remembering the steps can take a little bit of time. So go to the next page. There's 2 more examples. The first one already has the constant term moved to the other side. We can just do what we did on the previous page. The second one doesn't even look like a quadratic, so our first step is to make sure it looks like a quadratic before we can go ahead and follow the procedure. So pause the video, try number 1, and then come back, and then you can try number 2 and come back. Okay, so we move the constant term to the other side. That was already done for us. Take your b term, divide it by 2, and square it. We get 9. We take that number and we add it to both sides of our equation. We reverse FOIL this side, x plus 3x plus 3. 11 plus 9 is 20. We take the square root of both sides. We move the 3, subtract 3 to move it to the other side. We get negative 3 plus or minus the square root of 20. We need to simplify 20. 20 is 4 and 5, which is 2 square roots of 5. And that's our answer. For the second one, first thing you're going to do is multiply through by x. So you get 23 equals x squared minus 10x. Now you can see it's in the same form that we were here, where the constant is on the opposite side. You can rewrite it if you want the constant over here, but otherwise do the same process. Take your b term, divide it by 2, square it, add it to both sides, reverse FOIL, and continue to solve. Okay, so we have 23 equals x squared minus 10x. We took our b term, divided it by 2, squared it. 5 squared is 25. We add the 25 to both sides. Combine this, get 48. Simplify this by factoring, or what we call reverse FOIL, x minus 5, x minus 5. Take the square root of both sides, add the 5. (48) is 16 and 3. So 48 simplifies to 4 square roots of 3. And you have 5 plus or minus 4 square roots of 3 equals x. So next page. The last thing that we're going to cover, we're not going to do this today. The ones that we looked at so far, the leading coefficient was 1, meaning x squared was just had a 1 in front of it, right? X squared. So the next thing we're going to do is look at what happens if it's not a 1, if the leading coefficient's not a 1. So we'll practice some more completing the squares in class. And then we'll talk about how do we do it if it's not a 1 as your leading coefficient. So I will see you in class. Take care.